Good afternoon, everyone, and welcome. I want to thank Professor Hajjar once again for an awesome talk. It was everything we had expected and more. And welcome to this panel discussion, the topic of which is designing for climate change and sustainability with civil and construction engineering perspectives. My name is Amit Verma. I am a faculty member in the School of Civil Engineering, and I'm also the director of Bowen Laboratory, and I have had the privilege of having Professor Hajjar on my PhD committee, yes. which is my claim to fame. It's such a pleasure to have Professor Hajjar and also this topic. And I want to introduce our panelists. I'm going to start off with Dr. Jin-Ha Jung. He's an associate professor in the School of Civil Engineering. And he is noted for his work in the development of UAS-based high-throughput phenotyping system for agriculture applications, developing algorithms to process UAS data for feature extraction, data fusion of hyperspectral and full waveform LiDAR data, and for WebGIS software using free and open source software. Right? Please welcome Dr. Jung. Heather Lytle is an assistant professor here at Purdue with a joint appointment in mechanical engineering and environmental and ecological engineering. Her research focuses on technology and systems strategies to improve resource utilization and adverse environmental impacts of manufacturing. Heather has her BS and MS in mechanical engineering and a PhD in material science. Satishu Kusuri is a Riley Professor of Civil Engineering and the campus director of the US DOT Transportation Cybersecurity and Resilience Center, TRACER. He has been involved with community resilience over the past 20 years with expertise in network science, AI modeling, and interdependent socio-technical systems modeling. He has published papers in journals such as Nature, PNAS, Nature Communications, and also discipline-specific journals. He's the co-editor-in-chief of Data Science for Transportation and a co-editor-in-chief of ACM Journal for Autonomous Transportation. And Dr. Miriam Lizankos is an assistant professor at the Lyle School of Civil and Construction Engineering. She's the associate director of PanCow Lab. She specializes in sustainable proactive cementitious composites, CO2 capture, waste valorization, durability, and life cycle assessment of construction materials. She has published numerous papers in these areas and filed several patents in sustainable construction materials and CO2 capture technologies. She has been an invited speaker at many universities and conferences worldwide. The way we're going to do this panel session is I'm going to request, thank you. The way we're going to do this is I'm going to request our panelists to speak for a few minutes on the topic of discussion and their perspectives on it, just about 3 to 4 minutes or so. And that will allow us to then get into the topic of discussions. And I have some questions that are going to stimulate discussion between the panelists themselves, give us an opportunity to hear their collective perspectives. I'll pick about 4 or 5 questions from the list that I have, and we'll discuss them for about 5 to 6 minutes each. Request 2 or 3 of the panelists to provide their opinions in less than 2 minutes or so. That should still leave plenty of time for questions from the audience to stimulate additional discussion with the panel. So this first part is about 5 to 10 minutes. The second part, which is now where we're going to hear from them, is about 20 minutes. And then we'll have about 20 minutes of guided discussion between the panel, and the rest of the time will be for the audience. So I hope we have a great panel and a great discussion here. So we'll start off with Dr. Jung.
Okay, nice to meet you. My name is Jin-Ha Jung, and I'm associate professor in Lyle School of Civil and Construction Engineering, and currently leading the lab named the Geospatial Data Science Lab. So we do deal with geospatial data a lot in our lab. And when I was recommended or invited by GS to, participate this panel about sustainability and resilience, and what can I talk about it. And the one thing that I came to my mind is that how can I connect this with the geospatial data science that my group has been working on. And we are living in a world where we have a lot of data, information is floating around. Probably all of you guys are active YouTube users, so we watch YouTube a lot. The reason why we can access all those kind of video content is we do have such a platform where we can easily access this kind of information very, very quickly. And if you look around and who is making this AI innovation at this moment right now is all those big tech company like Facebook, Amazon, Google, and they all have one thing in common. They are the one who has access to big data set. So looking back how this geospatial data science it can be a part of this kind of new data-driven AI model development. And we like to call this as geo AI instead of just AI, because AI is in a very bigger umbrella. But going down a little bit, narrow down, we'd like to have geospatial data related AI stuff. And we are living in the world where not only all those text, the video information is going around everywhere. We start to going to a moment where we start to generate a lot of geospatial data as well. In old days, geospatial data set used to be generated by big players like NASA, or federal agencies like USGS, or European space agencies, and etc. But now you probably heard of the term drones. Drone is not the the big the bird, up in the air where you can, drop a bomb or something. But you can go to the Walmart, for example, by a drone, and you can generate beautiful, high quality, geospatial data set. So in my opinion, hardware is, reaching to a moment where everybody can generate this kind of big geospatial data set. But what the area that is lacking at this moment right now is that we don't have such an ecosystem or centralized repository like in YouTube, where you can actually manage your big geospatial data, also make those data sets accessible to everybody, so that those other research disciplines can take advantage of this geo AI to do this kind of development. So that's where my research group is kind of focusing on right now. How can we build such an ecosystem where this kind of big geospatial data set becomes, we like to call it fair, findable, accessible, and interoperable and reusable. So those are the areas that my group is working on, and I'm hoping that this becomes a foundation to make all the other disciplines to take advantage of this geo AI technology to make their discipline more sustainable and resilient in the future. So.
Thank you, Dr. Jan. Go ahead, Evan.
Okay, thank you. So the panel discussion topic was, I think, civil and construction engineering perspectives, but don't be deceived, because I'm actually not a civil or construction engineer. So I'm from mechanical engineering, environmental and ecological engineering. So I'm going to bring a environmental sustainability perspective to this. So I wanted to start at the really high level with respect to environmental sustainability, just with what we mean when we say the word sustainability. And I noticed that in your lecture there, Dr. Hajjar, you also remarked on this. Like, my definition for this purpose is, and I think you had a great definition there about dramatically reducing greenhouse gas emissions and material reduction, which I think is great. But I think everyone is kind of thinking about a different thing when they hear the word sustainability. I mean, there are all manner of aspects that are incorporated into environmental sustainability, social sustainability, economic sustainability. All of it is important, but everyone's kind of value system, prioritization is different. So I think this can present a challenge for us as engineers, because as engineers, we tend to be really good at solving problems, but it can be really difficult to define problems correctly when the definition is really tricky and based on kind of subjective judgments about what we're actually talking about. So that can cause, I think, some communication challenges where we're potentially talking past each other when we're trying to to resolve issues that we all agree are the issues, but maybe we don't quite have a common understanding of or consensus on how to address them or what the issues even really are. With regard to urban infrastructure, buildings, bridges, roadways, these are inherently designed to last a long time. So we know that, right? 30, 50, 100 years, 200 years, not unusual for some of these structures. And then we're talking about goals that are, net zero by 2050. And so when we put those together, it causes some challenges and maybe some even cognitive dissonance in terms of how are we going to address these challenges? We want to be net zero by 2050, but we're building buildings now that are going to last well past 2050. So what's kind of the time component of the decision making, and how should that impact what we're doing as engineers and the solutions we're coming up with and how we implement them? So I guess I wanted to just close with talking about predictions. I think predictions are kind of a hallmark of sustainability, risk, many of the topics we've been talking about, and predictions are really, really challenging. So the ability to make good predictions is really important. I think systems thinking is really important. Techniques like the ones I use in my field, life cycle assessment, are important. But in general, I mean, Yogi Berra said predictions are hard, especially about the future, and I think that's really right. Thanks.
Thank you. It's a great pleasure to be on this panel with everyone. So my journey into resilience started in 2005. Can you hear me? Yep. So 2005 with Hurricane Katrina. And after that, we had done a lot of work with various hurricanes. Hurricane Ida, Hurricane Harvey, Hurricane Sandy. So we have collected data related to response, recovery, and resilience for many of these hurricanes, right? So, but some of the central questions that we are interested is, why do some cities, some communities do better as compared to other communities? So Professor Hajjar mentioned about Kobe earthquake. Like Kobe recovered much faster, whereas New Orleans has not recovered very well after Hurricane Katrina. So what are the differences that actually explain some of these things? Those are the questions actually which drive us. And so we are interested in exploring modeling related issues for those questions. So there are three thoughts which I wanted to kind of share with you related to some of the salient things that we actually see. One is the role of networks. How do social networks and physical networks play into the resilience of these type of communities? The second is what Jinha mentioned about data and the role that AI and data play into modeling these systems, understanding the movement of people. We really look at how people move during these types of disasters. What can we learn from these types of movements? I think that's the second important issue which we would like to kind of think about. And finally, the role of equity. Not all communities, not all people within these communities recover in the same way. So there are differences with respect to race, income, where people live. So we need to recognize the role that equity plays in terms of the recovery of these communities, right? So one, how can we harness the power of the networks in terms of improving the recovery? Two, how can we use data to understand these types of issues? Three, recognizing equity as something which is important that we need to handle, not at the back end, but from the very beginning in terms of how we look at these issues. So I think we can kind of discuss some of these issues during this panel. I'm really looking forward to kind of having a very good discussion here.
Okay, well, first of all, thank you so much for the organization to inviting me to be part of this panel. It is really an honor to share stage with such a great minds on the area of civil engineering and also economical engineering. So that's great. Since the topic of the panel is related to sustainability and my expertise is on civil engineering, I just wanted to focus my remarks on the role of construction materials and sustainability, and also on my vision of future paths that might have the opportunity to help the built environment to be part of the solution instead of part of the problem. So to do so, I will just give you an example which is related to concrete. Concrete is the most used construction material in the world. It's everywhere. It's in the foundation of this building. It's in the roads, bridges, and so forth. And you might have heard for sure that concrete has a huge environmental impact. Like cement, one of the main compounds of concrete, is just responsible to, I think, 5 to 8% of the global CO2 emissions. We mined more than 300 million cubic yards of rocks to produce the aggregate that we need to produce concrete every year, only in the United States. So we have to do something about that, right? And, our community during the last decades did a lot, and we progressed a lot in the right direction with research on waste valorization, with research on use of alternative binders that have, lower CO2 emissions related, and many other things, many other approaches just to reduce the environmental impact of concrete production. But I think we should go even further. While all this research is very important and there is a long path on that direction, also we have to even think about what we can do to make construction materials, concrete and others, to work for us. How to do it? Of course, this is just not magic, right? This is why part of the research that we are doing now is focusing on providing concrete with proactive properties during their service life. What is that? This is just, for example, I'm talking about creating bioreceptive concrete that can be used to create resilient and sustainable green building facades. These green building facades can help us to clean the air in our cities and also fight against urban heat island effect. That's just one example. I'm also talking about, for example, concrete that can capture CO2 or can decompose NOx or CO2 with photo reduction in a more efficient way. And these are just two examples of many other ones I can give that are related just to concrete with an active role and just not a passive role. So these are just some examples, and developing these technologies and many others is very complex. And it's very complex because several reasons. First of all, of course, this is all based not in magic, not in wishes. This is based on basic science. This is based on a fundamental understanding of the microstructure of the materials and their interaction with the environment. But we are talking about civil engineering materials. So since we are talking about civil engineering materials, it's just not we need to understand how it works, or we don't need to just know how to make them. They have to be, the method to make it has to be scalable, it has to be cost effective, it has to be technically feasible. So that's very challenging, and this is kind of the beauty of civil engineering research, not only in materials, but in any other area. We are talking about very complex problems that can have many constraints and many things that we should account for, and then we'll have a great impact in our environment, in our research, in our economy. And again, that's just only an example in materials, but any other area of civil engineering has kind of the same flavor, I think.
Thank you, all of you, for the introduction and the discussion points from the panelists. So what we're going to do now is take a few minutes to stimulate some discussion between the panelists themselves. And I'm going to pose some questions that I've collected over the past week or so from different faculty members within the school. I'm going to start off with a tough one. I'm going to start off with a question that talks about, when we talk about resilience and when we talk about sustainability, are these two design functions coherent? Or do they produce challenges? As you make something more resilient, how do you continue to make it more sustainable? Especially given the fact that resilience usually stands for strength and sustainability usually stands for efficiency or economy. So from your perspectives from different fields, how do you reconcile the two? Go ahead.
Oh, okay, I can go first. Great hearing about your comments. Thank you. So I believe that resilience and sustainability are not at odds. There's some overlap, and so perhaps each can stand on their own a bit, but I absolutely think they can be integrated. And first of all, being able to bounce back quickly after extreme events and not condemning our buildings is certainly one component to sustainability. And so making sure perhaps, there's discussion, we're a long ways from starting to extend the life for which we design our structures. Oftentimes it's about 50 years now. Will we get to 100 years or beyond? But that's a very simple example about how these can be integrated. And as you're designing your resilient structures, you design them keeping sustainability in mind. I think these can be completely integrated. I think I am unconcerned about having these be at odds with each other.
Sounds good. Anybody else wants to chime in?
Well, I think it's kind of a must, right? We have to have both. And the reason is because it's resilience and also durability. These are just two parts that should be part of the life cycle assessment and on the sustainability analysis of the structure. If we are dealing with a temporary structure, no, but if we are dealing with something like a bridge, of course, durability and resilience are part of the sustainability approach. If not, I mean, we are not doing it right. If we have to rebuild it again and rebuild it again, I'm sorry, that's not sustainable.
I mean, I think resilience for a community, if it is very resilient, then it's also going to be sustainable over the long term, right? But I think when do you really address that resilience is really important. So if you're only resilient after an event happens, does that contribute to long-term sustainability? That's, I think, something to really explore further, right? I think resilience should be something which should be before. So can you really understand, for example, in the work that we have done, what we have seen is when communities have strong social networks, strong bonds, before, like this is not after the disaster, but before the disaster happens, those are going to recover faster, but they're also going to be much more sustainable in the longer term, right? So I think, as Jerry mentioned, these are not at odds together, but the timing at which we kind of make these systems more resilient is something important towards long-term sustainability.
I think I would just come back to the definition of sustainability. I think a lot of times we do not use sustainable to mean the literal definition of sustainable. But if we think about it in this context, like able to be maintained for a long term, I don't think that's in conflict at all with the concept of resiliency. In fact, I think it's quite harmonious. So I think one of the challenges with sustainability is we've started to interpret it maybe to mean resource minimization, whereas actually we are talking about resource optimization, which does not necessarily mean minimization. Lifetime extension through resiliency efforts is absolutely a sustainability strategy.
That actually was a great discussion and actually leads into a follow-up thought on usually when we design in the built environment, often the owner or the person financing or the institution financing has to make a choice between low-cost incremental improvements versus higher cost but potentially transformative overhauls. And given our definition of sustainability and the cost of money and the unpredictability of the capital market, what are some recommendations about weighing incremental versus transformative improvements in this context? That's a tough one, huh? Yeah, so.
I can go.
Yeah.
Yeah. So this is an all-hands-on-deck effort. And first, I talked about trying to have some policy shifts. Spoke about the person from the DOD and the GSA, and if those two organizations alone start to incentivize these sorts of solutions or require these sorts of solutions, that will help integrate some of these goals more deeply into the profession. Second, it's on the engineers to try to work with the owners in ways that the owners understand to show some of the potential benefits. The reason that LEED has had some success and what the U.S. Resiliency Council is trying to do is because owners recognize that they can sell better their structures, their buildings, if they are LEED certified, if they are more resilient. This is still growing, and so we have to work with the public to see the value in that. And I don't want to be naive to say that these solutions won't necessarily be more expensive, but I definitely think a lot of them can be very cost neutral, if not shown to be cost effective. And so I think we have to work on that pretty directly.
So I don't think there's a right or wrong answer for this one because either way can be correct in the long run. Because being in academia, I think one of the biggest advantages in academia is that you can try transformative ideas without losing my job or getting bankrupt or something. I think that's one of the benefits of being academia. I believe that Purdue is in a frontier doing this, trying innovative ideas that might end up being that most transformative the solution to some of the challenging problems. So to going back to your answers, I don't think we have only one way to pursue that, but especially as the faculty in academia, I think I love to try those transformative ideas without being risking how should I say that, without worrying about failure. And that's the place where we can make innovation, and I think Purdue is very well known for this kind of innovation.
So is the question whether the trade-off of resilience in terms of the...
No, the question was the trade-off of low-cost incremental solutions, which may be less expensive, versus long-term solutions and strategies that may cost more right now, but have a longer range.
I would like to take the option, it depends here. So what does it depend on? It depends on the initial state of the system, right? So for example, like in Puerto Rico, like what's happening in Hurricane Maria right now, their power grid failed. The power grid is really not working very well. It's an opportunity to kind of reconfigure the system completely, right? But resilience comes with certain cost that you need to put into it. So in the resilience world, when people think about recovery, it's not necessarily coming back to the same state what it was before, but sometimes there's an opportunity to even make it better than what it was before. And this is one of those examples where a transformative change can actually be made because that opportunity exists to do that. But for some systems, the initial state itself is pretty good. There are perturbations, there are disturbances, there are shocks that actually happen. And so you can only make incremental adjustments to the system, and the system works perfectly fine, right? So the initial state really is what determines how much of cost, what type of retrofits we actually need to make.
Excellent. If anybody wants to add anything, let me know. Otherwise, we can actually ask a related question. As sustainable solutions, they shift the focus to design to solutions that are going to benefit future generations that are coming much later. But societal acceptance of these solutions can be somewhat challenging. So what role do you perceive? Yeah, I'm sure there's plenty of roles, but what specific roles do you perceive for social scientists to play in this regard as we incorporate them within our profession?
Well, I think, okay. You want to go first? I really think the role is it will be very critical. It is very important because at the end of the day, we need to, it's not just we have a good technology and it works, and even if it's cost effective, we need to have the acceptance of the public. And that's something that, engineers, we are not trained to kind of understand that much, that area. For now, we should do better in that area, I will say. But I think, there is even a little bit of unconscious bias. For example, I was talking to cement producers, and they say, we have even an option that is more sustainable, and it has the same cost. Still, people, they think it's more expensive. And the problem is when you kind of explain, no, it's not more expensive, you can do the same, it's same cost, still they say, then it's worse. They say no, it's not worse. So this type of thing is just, okay, we can do the material better, it can be more sustainable, but then we also need to work with a multidisciplinary team to understand what are the barriers and to try to just transpass these barriers.
We have been working with social scientists for almost 20 years, both at Purdue in communication and philosophy and also outside Purdue. I think these problems, if we want to make an impact, you really need to take a socio-technical approach towards solving these problems. Because finally, these problems need to address people, communities, and the disciplines which actually focus on solving people's issues are in social sciences. Why do we say that? One, because there's a huge diversity and heterogeneity of people that we need to address. We need to understand the attitudes, norms, and trends of how people think. We need to really go to the field and collect data. And we might be doing the modeling, but we really need to know how to collect the data, how to build trust within that community, and that's what social scientists are very good at. So we actually work with many of the social scientists to actually do the data collection, to understand the behavior, to understand the attitudes and the norms of those communities, to build the trust, and so on, right? So we can build an agent-based model, but we make the assumptions that go into the agent-based model have to come from data and from collaboration with social scientists. Otherwise, the agent-based model is not going to be useful at all, right? So I think social scientist collaborations are very critical towards actually making an impact in this field. And Purdue is actually, I think, a leader in doing that.
Yeah, I can add that the project I showed on transmission line towers, I mentioned there was a computer scientist doing agent-based modeling of modeling people before, during, and after the hurricane. He was working with a sociologist who understands how people think before, during, and after extreme events. And in fact, there's all sorts of industries that look at how people behave. And the whole world of Amazon and feeding you stuff that you want to buy is looking at behavior. Architecture essentially is understanding and integrating how people behave and how people want to think about their spaces. And there's a whole range of other examples like this. Integrating human behavior. I have a colleague at Northeastern who's working on basically how to study human behavior to reduce the amount of energy they use to heat and cool their houses. And if you can encourage them to change their behavior, that alone can make a big difference. I think years ago, the Secretary of Energy said, if we can figure out how to convince people to have white roofs instead of dark roofs, the amount of energy would save is huge. But nobody wants to put white roofs on their houses. Yeah, this is a human behavior issue, and integrating that into our own work, I think, is vital.
So, as an engineer, I'm my apology if I'm just defining social science and outside what it is. But I think one point that I'd like to make here is that we need to be aware that things that we develop, can be used in a way that we never intended to. I think one good example is an Oppenheimer. There is a study that's in a good intention, but ended up being a deadly weapon in the end. And a lot of times as an engineer, we like to develop technology without thinking about how this is going to impact human life. I think we need to be aware of this. And especially in the context of an AI, sometimes this AI is getting scary. A lot of times they do things that I can't. And some of those generative AI, they can generate those photos and videos more realistic than I can that detect whether this is real or bad. And a lot of times, and I rely on Google Maps when I'm driving, and I don't know where I'm going. I'm just driving wherever this Google Map tells you, turn left. I'm just turning left because the machine is telling me to do so. And a lot of times, I used to go this route, but it is pointing me to the other way. Is it really because I can get there faster, or is it because Google want me to reroute me to some other places for some other reason? So the point I'm trying to make it here is that we all, as an engineer, we are very good at developing this kind of technology, but I think we need to be careful and be mindful on how this technology or the new things that we develop might end up affecting all this in human life.
Unintended consequences.
Just to clarify, when I say we should do better on working with them, I was more talking as part of the construction materials industry. I mean, in other areas in civil engineering, there is a long path already on that direction. But I really think construction materials industry in general is just not that connected. We are just so focused on making better materials, but we need to do better in that direction. That was just.
We need sustainability to go viral.
I'll just ask one more question on behalf of the faculty, and then I'll go to the audience in a moment. There is a monster in the room by the name of AI and machine learning. And we've touched upon it a little bit. It's not been the central theme, but what is the role and the integration of AI and its various tools within understanding climate change, designed for resilience, and then sustainability? What are your perspectives on how AI is going to transform the application of all of these in the next several years?
I am not going first.
Satish, you want to take it?
Well, I think I asked that question. So, I mean, in our work, we see a lot of promise of using AI, right? Especially, we have the capability to actually have very detailed data of individual movements of people. Although the data is protected and there's privacy and so on, we can infer the home location using heuristics, algorithms that we actually have developed and so on, right? So sometimes it's scary, although we are actually using all the protocols of data protection and so on. It's scary what we can know about the individual or the community in terms of the type of choices they make in the real world, right? And the data we have used is primarily cell phone data of people movements, geolocation data. We have used Twitter data and so on. And so we can learn a lot of things from this data by building graph neural network models, physics-informed machine learning models in terms of where people are moving after a disaster, when are they coming back, who is coming back, right? So we can also correlate the reasons of why they're coming back with respect to the damages that are there in the community, right? So we can kind of really harness the data very well by creating models. We can do predictions too very well with this kind of models. But it's sometimes kind of scary to kind of see the data that is actually available to us. And so I think right now we are at that stage where we don't recognize all the pitfalls that are there with these types of data and models. And especially the data, I think we are behind the curve in terms of how to protect this kind of a data. And also models, I think, with the ChatGPT type of models and the different types of learning models that we are seeing, I think we are still kind of behind the curve in terms of how to protect the privacy of many of this data that is actually available.
So maybe I can add on top of that one. I think I already mentioned that AI can be scary, but I think that this also goes into the in our education as well. Whenever I'm just teaching a course, students submit their work. Sometimes it reads so well, and I have to kind of give suspicious look at, is this really your work? But there's no way I can know whether this is done by the student or anything else. But the point I'm trying to make here is that we need to be mindful about this technology. And there's one time I saw internet cartoon that is kind of sarcastically saying the danger of this in AI. It says, we develop AI so that the human can do creative things, not the kind of repeated work. But the way how this ChatGPT is doing to us AI is doing creative work, which first, draft the writings. Then we are going into and trying to fix all those kind of, repeated in a simple kind of task. So the point I'm trying to make here is that we need to be mindful when we are adopting or using this in AI, so that this is going to be actually helping us to do what we want to do instead of being blindly kind of instructed by this in the AI. I think that that's one thing that I want to talk about. I think that the other point I want to make, that Satish mentioned about equity. This AI becoming the big play in AI is in OpenAI right now. As the name suggests, it is supposed to be open, but the company is not opening everything. They're making big money out of ChatGPT as well. So how can we make this in AI to be equitable to everybody? I think that's the part that my group is developing, and everything is an open source and making it available so that everybody can benefit from it. But I think as an academics, we need to be mindful of this kind of technology and how can we use this technology to do what we do.
So I would like to add a couple more points. One is related to the bias that is there in the AI, right? So, for example, there have been studies where they've shown that because the AI is trained on Caucasians, when it kind of sees a African American and a brown person, it's not able to kind of recognize at the same level, right? So and similarly, we see in our location data is highly representative of high income, high density locations, but not low density locations. So there is inherent bias in the data. And so we really need to be careful when we make the inferences with respect to this data. Two is the trustworthiness of the models itself, right? So, and interpretability that comes with these models. So we need to be very careful in terms of how we interpret the outcomes that we actually come from these type of models, right? So I think that's a whole discussion in terms of the trustworthiness and the interpretability of these types of models. So I think there's a lot of caution and caveat that we need to put when we kind of use AI, because that's becoming a buzzword and I think everyone is actually using it.
I'd like to open the floor up to questions from the audience to continue stimulating the discussion on the subject matter, and you've got quite a panel that you can pose your questions to. We couldn't hear you.
Thank you. I'm an electrical engineer by training, and I came here just because the topic was so interesting. I was wondering that how do you design long-term structures when the technology is going through such rapid change? And by that I mean that the rapid electrification of everything. Cars in particular, when you have cars, each one of them having batteries embedded in them, do you design the buildings the same way? Because now, if the buildings are sort of reflective, then you can harvest that energy and store it in the car, and car can take that extra energy away from the city. So the heat islanding effect would be different. Do you need to put as many sensors as before? Because now the images that are being taken by the car is actually also imaging the buildings. And any cracks or infrastructure related issues, those can be also harvested from this data. And what about charging the highways where you can charge as the cars sort of run through, because the lines are sort of embedded under the highway so that you can harvest the energy as you're driving the car. You don't have to stop in a gas station, for example. So it seems like that anything that we design today will be obsolete in 20 years. And these questions about sustainability and other things seems to be a very difficult question in this context. I was wondering, what do you think if an electrical engineer asks you this question?
Well, I think I could start by saying that, yes, these are very complicated issues. I think we can all agree on that. And, of course, it's an evolution. Heather was talking about definitions of sustainability and all, and if we're designing structures for such long terms, what does that really mean when we say by 2050 we want X? I mean, I'll define it by saying the stuff we build in 2050, I hope, can be towards a net zero emissions economy. And then we have to go from there. But these things evolve, and I think that's okay. I mean, there's all sorts of jurisdictional complexities in some of the innovations that you're proposing. I know for roadways, in fact, right here at Purdue, they're working on relatively inexpensive sensors to mount on standard vehicles that can actually detect potholes and things like that. So I think there's a lot that can be done. But, out in the East Coast, I'm used to purchasing 100-year-old houses. And takes some effort to actually just get electricity into some of the rooms. And so it's going to be an evolution. It's a big question, so I don't know. But I think, if we move towards trying to integrate more of these solutions into our designs, that alone could be significant progress.
So I don't design large structures, but I do think a lot about lock-in effects, technology lock-in effects. I mean, mostly in the industrial sector in my case, but modeling that and thinking it through requires kind of a crystal ball as far as, well, what's coming in 10 years? So if we overhaul this factory or this bridge or whatever that might not need immediate replacement now, what's the outcome of that? If we had waited 2 years, if we had retrofitted this instead, or if we had drastically changed it, we'd ripped it out and replaced it altogether, what's the implication of that for the environment? And so that's something that we try to model, looking at, we talk about technology lock-in, design lock-in, but we also talk about carbon lock-in. What's the carbon lock-in effect? And so we had the experience a couple of years ago, maybe more than a couple of years ago now, with the fracking boom. We had access to really low-cost shale gas, and a lot of corporate entities decided to overhaul their factories at that point to make use of this shale gas. And honestly, it was an improvement because maybe they were using coal before and now they're using gas. So that's a little bit better, but they've locked it in. So instead, had they not prematurely retired their previous assets and they had waited, well, they didn't want to do that because this was a competitive opportunity, of course, but had they waited, they could have had access to something that was more sustainable. And so in the chemicals industry, for example, we saw that emissions were going down, and then they actually slightly increased per unit of production. And it seems to be tied to that fracking, kind of shock. So I think that sort of thing we need to be cautious about. And so I think there's a role for the government, leading the way. I think Dr. Hajjar was talking about that with GSA and with DOD. And there's also Buy Clean, a policy for federal procurement of construction materials. And that leadership, I think, can be really powerful in terms of culture shifts and ensuring that things are moving in the right direction.
Can I add one more? So I think that to answer your question, how can we make this sustainable for longer term? I think one of the key factors is openness and transparency, because we are living in the era where a lot of data is being collected, but a lot of times this data set is not open to public, or at least kept by certain stakeholders so that they can make business out of it, etc. If you look at this software the market for the last 10, 20 years, 20 years ago, Microsoft was dominating this computer operating system market. They have a closed source. They are counterpart, which is in Linux, all those, the GNU Linux, the group, and all those kind of stuff. At that time, everybody said, hey, this open source is not going to work because you cannot make money. But look at now, all those innovation is happening from open source project. Now, even Microsoft is one of the biggest donor to this open source project because they benefit from it. So, going back to your question, the question here is that I think making it open and transparent, and also having the equitable access to this kind of data set, I think it's going to be one of the key things that we have to keep in mind, that that's the way to be sustainable in this kind of technology for a longer term.
Any other questions from the audience? Yeah. Okay,
Well, it's to the camera.
it's for the recording.
Yeah, it's so the camera can get you. Thank you.
Yes.
Hi, so I'm a master's student in structural engineering. I went here for undergrad as well, so I got my technical expertise from Purdue University, which does a great job of teaching you like all the technical information. But on a sustainability side, I've realized in academia it's not always highlighted as much, especially when you're just learning about your basic mechanics, all this kind of things, that it's not really highlighted until maybe later on in your undergrad, and then in grad it's really highlighted. So as just like the younger engineer that's going into industry soon, what are some recommendations you have to, because like I've worked internships and they're like, be a sponge, learn as much as you can. But like sustainability wise, what are ways that I can learn these like concepts as well as learning your just overall structural concepts that you need to know as a structural engineer?
Okay, I could start with that. And lots of different things we could say here. First, if you want to come get a PhD with me, we can talk after. That's a very direct way. You can come get a second master's in our MS for Sustainable Building Systems. We are, let me just talk systemically for a moment here. We produce a lot of engineers, of course, just like Purdue does, that go to firms, including in the Boston region. And we have one great firm that's there, and they have a lot of our graduates. And about 2 years ago, several of them contacted me and said, as soon as we hit the firm here, we're being asked to address sustainability in our solutions, and we really didn't learn about that much. And so I started a series of meetings with them where we're going through with them what they're seeing and what they wish they had learned. And since they went through our curriculum, they're actually going through with us course by course, helping us even develop homework assignments and so on. And so the structures faculty are very excited about this. We have a whole theme of sustainability and resilience for our structures faculty, and because we're doing so much research in it, and we're integrating it now into our curriculum up and down the system. It's going to take a while. I'll also say that's a first step towards a bigger mindset shift that theoretically has already happened in the UK. Our entire engineering curriculum is geared for, in my opinion, new construction or new products for wealthy owners. Not nearly enough thinking about equity issues and a much broader set of the population. But in the UK, they're looking at repair, retrofit, renewal first. That's what they're teaching first. Integrating that as a mindset before they get into new construction as a last resort. So that might be ways we can address this. In terms of how you could do that, do this after you graduate, there's lots of stuff going on in the professional organizations that would help you learn about this. Structural Engineering Institute, National Council of Structural Engineering Associations, there's Green Build Conference. If you go to the Structures Congress now from SEI, it's really interesting. You can see the shift in our profession. 5-6 years ago, there was maybe one session struggling to get attention. Now, half the sessions are on sustainability and resilience. We are building into ASC 7, the National Design Code, a whole new chapter on how to integrate the impact of climate change on our loadings. There are technical committees that you can join, and you are qualified as you sit there right now. There's conferences you can go to. There's webinars you can listen to. I put up Tanya DeHogue, support technical innovation, lifelong learning, act together.
You're a master's student in structures.
Yes.
So I think it's also good to kind of go outside structures and explore all the other sustainability options available on campus. Are you familiar with the Institute for Sustainable Future?
I am not. No.
So there's an Institute for Sustainable Future in the Discovery Park District, and they organize various events related to sustainability, including seminars. There's also events for graduate students, and they do a sustainability campus report every year in which students are involved. So there are a lot of things going on campus related to sustainability, which are not directly related to structures.
Okay. Definitely look into that.
And I think Professor Verma leads a program on sustainability and resilience within civil, right? Yeah. The online masters for.
You want to add anything?
I was just going to add a brief comment. To feel empowered to learn things on your own, if you still have an opportunity to take coursework, there are courses available that you can take that you could talk to your advisor, and I'm sure he or she would support you taking those types of courses. But you can also learn on your own. And honestly, that's how most of us did, because mechanical engineering, I mean, when I graduated, there was not one sustainability course that I could have taken in mechanical engineering. I didn't get any sustainability education. I decided I wanted to do that professionally and just kind of learned it as I went. And now I'm a faculty member in a sustainability-oriented department. So, I mean, if you empower yourself, I think you can do more than you might imagine.
Thank you. I just want to make a closing remark. Your question is fantastic. You saw how much response you got from the panel and from everybody. So was yours. It's clear that sustainability, climate change, resilience, AI, these are all very complex problems. But my closing remark is this. Yesterday, I was involved in a meeting for a mega project, mega civil engineering project, something that is bigger than anything else that I've seen. And there were multiple structural firms, civil engineering, construction firms in the same meeting. And we were all talking about how challenging the project is, how difficult the forces are to design for, and how big everything was getting just to meet the requirements. What was never asked in that call was, is this structure resilient? Are my materials sustainable? Is that even a design function that I need to worry about? So what I would tell you, and I would tell all the students, is ask the question.
Yeah, man.
That is the right thing to do. It's not something that can be taught or self-learned. It is a changing goalpost, as he pointed out. Today, sustainability may mean something else. 20 years from now, it may mean something else. But the fact that our graduates will go out there and pose that question in that very difficult project room when something huge is being designed, and raise your voice, don't be afraid. People have just forgotten to ask that question. You may be the first person who raises it, but believe that there are other people in the room who are going to back up and say, oh yeah, we forgot about that. Let's talk about sustainability. Let's talk about resilience. More than just the functional requirements, more than just the requirements that we're trying to make the structure, let's talk about it. That really is the message that we wanted to give. Raise the question in that project room. You may be the lowest person on the totem pole there, but nobody will remember that. Everybody will remember the question. Yeah. So I want to thank the panelists. And I want to thank you all for coming. It was a fantastic session.